While simple random samples are sort of the gold standard of sampling, they're not always possible, or even if they're possible, they're not always feasible. So there are a couple of other types of sampling techniques that we're going to go over in this lesson. The first is a systematic sample. And so what this is it's that you sample every nth member of the population. So for example, if I want to do a systematic sample at Wilson Prep, I would sit down with that list of emergency cards and I would go and pick every, let's say, 12th emergency card, and I would go and talk to that student. Or every 15th one, or every 3rd one. It doesn't matter, it's just every whatever nth number. And so that has a couple of advantages. It's still pretty random as long as the ordering for choosing is unrelated to the characteristic of interest. So if I'm asking students about how satisfied they are, I don't think if I line them up in order of name from A to Z, or even if I have them in the little book in order of grade, I don't think if I choose every 5th person and go all the way through the school, that it just so happens that every 5th person is like really, really satisfied with the school. I don't think that that order that I'm picking from is going to be any way related to the characteristic of interest. And this is easier. This is the reason this is used instead of random sampling sometimes, is simply that it's easier. So for example, when I was in grad school, we were emailing people to survey, and so I just took the student directory, and the researcher who I was working with just said, make it really simple for all the research assistants, just email every 7th person. That was it. On the downside, it may be biased if order is related to the characteristic of interest. So if I'm taking a random sample of days in the Bay Area and I'm trying to find the average temperature, then if I select every 365th day in a whole bunch of days, well, I'm getting the same day every year, and if that's August, then it's going to be a lot hotter than the rest of the year. So that sort of thing you have to watch out for. Also, it has to be possible to order the members of the population. And it's not truly random. So as an example, pick a 16-person sample from a group of 76 people enrolled in a summer program. So the way we would do that is we would first order them. So this might be by last name alphabetically. Pick every 15th person on the list. And so when we got to the end, we would just start back up at the top again. That's all a systematic sample is. It's quite straightforward, but again, it's not as random as a truly random sample. Another type is a stratified sample. So in this one, we divide the population into groups. Based on some characteristic. So this could be gender, it could be race, something like that. And draw randomly within each group. So in this case, basically the two groups are sort of like two separate samples that we're taking. We take 8 from one, 8 from the other. The main reason that we do this is that it makes sure that we sample some people from small groups that are unlikely to be drawn from by random chance. So for example, if we are have a school that's mostly of one race, but there are a few people of another race, then we might not be very likely to get those people who are less frequent simply by random chance. So we want to sort of separate the two groups, make sure we sample some people from each, and then we'd have to use some techniques that are called weighting to sort of account for any differences that we see. But on the downside, it's more complicated, harder to do right, and often requires weighting. What weighting is it just means that you weight the responses of the people in the larger group more heavily than the responses of the people in the smaller group because there are fewer of the people in the smaller group. So to give an example of that, we're going to pick a 16-person sample from a group of 76 people enrolled in a summer program. So what we would do first is we would divide the population into groups, and let's say based on gender. And then we would use a random number table, just like we did in the previous lecture on a simple random sampling. And we would specifically just look at the men, for starters. So we would assign every male a number and use a random number table to pick 8 men. And repeat the procedure to pick 8 women. Okay. These are the two. So after the simple random sample, systematic is probably going to be the most often used, followed by stratified. This third one is one that's relatively rare, but it's kind of an interesting one. And the fourth one that we're going to talk about is one you should never use under any circumstances, but it is frequently used, and this is where we have some problems with statistics reported in newspapers. So the third one is called a cluster sample. And it sounds a lot like the stratified sample, but it's actually quite different. For data that is naturally in clusters, so for example, if we think about all the students in Oakland, they're naturally clustered into schools. Randomly pick clusters and sample every person in that cluster. So in this case, with the stratified sample, we separated it into multiple groups, and then from every group we took a random sample of people in it. Here, we're not picking every group, not every cluster. We're randomly picking a few clusters and then talking to every single person in that cluster. So this is used when it's extremely difficult or expensive to contact randomly selected people. Difficult. Here, I'll rewrite that. Dangerous or expensive to contact randomly selected people. Now, one of the most famous examples of this is right after the Iraq War, where researchers were trying to interview people in Iraq to figure out how many of them had been killed in the U.S. invasion. And obviously you can't interview dead people, but you can talk to their relatives and get a sense of how many of someone's relatives were killed. So the only problem was that this is what Iraq was looking like at about that time. So if you imagine some poor researchers going and listing all the people in the country that they could, randomly picking numbers, and then if you take like a little map of the country, and this is not going to be a very good map, but it looks kind of something more like that. And then they first talk to someone here, and then they go over and talk to someone here, and then 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 here, and so on and so on and so forth all over the country. Well, the probability of them getting out of that alive is pretty low. They're going to be dead by the time it's all said and done. So what they did, I'm going to redraw my generally terrible map of Iraq. And what they did is they said, okay, we've got all these little towns and cities that are all over the country. And what we're going to do is we're going to use a random number generator to pick certain cities. And it's easier to just get to 5 cities than it is to go all over the entire country. So what they did is they went to that city. They went to a specific spot in the city, and they knocked on all the doors within a particular radius of that particular spot. And so what they was able to allow them to do was to get a reasonably random sample and still make it out of the country alive. So cluster sampling isn't oftentimes used outside of war zones, unless it's something where it would be really, really expensive to go around and like randomly talk to every single student in, or randomly talk to every talk to every randomly picked student in Oakland. It would be far easier to just go to a school or go to a particular classroom and ask all the students there. On the downside, there's a greater danger that the sample will not be representative. This was a critique of the Iraq study that I told you about, which is, well, maybe they just happened to get some cities that had been really hard hit, and maybe if they'd gotten other cities, it would have been totally fine. So to give an example of this in the context of what we've been working with, pick a 16-person sample from a group of 76 people in a summer program who are eating lunch and sitting in the cafeteria in 19 groups of 4. I guess there are only 4 spaces at each table or whatever. But anyway, they're divided up into 19 groups of 4, and we need to pick 16 of them. So what would happen in this situation is that instead of assigning a random number to, or instead of assigning a number to each person, we would assign a number to each group. Then we'd use a random number table to pick. Let's see, there are 4 people, we need 16, so we would pick 4 tables. And then we would ask all of the people at each of those 4 tables. Notice how that's different from our stratified sample, where we randomly picked within each gender, but we sample people from both genders. Here we're just picking 4 tables, but we're talking to everybody at each of those 4 tables. Okay, the last type is a convenience sample. I'm going to tell you ahead of time, never use this. I list it because it is frequently used, even though it should never be by a professional statistician. So what this is it's just take the sample that's most easily available. So if I want to know who's going to be the next president, I would just ask my friends, who are you going to vote for president? The advantage is that it's very easy to do. The con is that your data is garbage. It might be purely by happenstance that you just happen to have friends who are a representative sample of everyone in the United States who's going to vote for president. It's not very likely. You're just as well off guessing as using a convenience sample. So nonetheless, let's give an example of what that would look like so you know what to avoid. So let's say they're sitting in the cafeteria, and you come in, you sit down, and then you just ask the 16 people nearest you. This is actually fairly commonly done if you sort of walk into the cafeteria and are just wandering around, asking people what they think about something. You're probably going to sort of walk down and get the 16 people who are just closest to you and easiest to get, but they may not, and probably are not, representative of everybody else. Okay, those are the 4 other types of sample.